So you're welcome back to the second part of this week 8 video, which is React performance optimization techniques, memoization. So this memoization in React is a technique used to optimize the performance of functional components by caching the results of expensive computation or function calls. It is particularly useful when dealing with computationally intensive or frequently called functions with the same output values, as it helps avoid redundant calculations and improve the overall efficiency of the application. So in other words, memoization is just like if the state of a particular variable or a function does not change, there's no need to recalculate, waste that time calculating or even rendering the page, as we will soon see. So in React, there are 3 techniques for memoization. The first one is React memo. So you're going to see how that works. Use memo and use callback. Now the React.memo is the first step. This higher order component wraps purely functional component to prevent re-rendering if the received prop remains unchanged. So that is what the React memo is used for. It can be used to prevent the child from re-rendering a child component from rendering each time a state in the parent component of this, and I'm going to show you a demo of that very soon. So this is how we do it. So we export defaults react.memo.post, so whatever the component name we want to use that. So the next one here is the use memo, but let's do that of the memo first. So I will come back to my VS Code. So the next thing I want to do now is to create a counter app. So do we have that? Or it must not be a counter app, it can be anything. But let's see if I have a counter component here. So no, I don't have. I only have what is so long. Okay, this was for my practice, so let's do that. So I'm going to create a component called counter2. Then let's create a component counter2.jsx. Then we'll have our array-fce. So we want to receive a prop here. Oh sorry, we don't even need this self, but let's just leave it. So we can do that. We can optimize this our page. Okay, of course we need that, we need that. Sorry for that. So we want to do a little bit of counter here. So let's counter set counter be equal to UseState. Then I'll put this as 0. Then I will have my function add count counter to be counter plus equal to 1. So then I can come down here, cut this and put inside h2, paste that. Then I need a h3 where I'll put my counter my counter there. Then I'll put an update button. So it's not compulsory I must use a button, so I'll put on click here. So I'll put my anonymous function set count. No, I'll call my add count and I invoke the function. So let's see how this works. So of course I need to import this into my optimization page. So I'm going to import it between these two lines. Counter 2, you recall. So if I save this now, I'll have it here. So you notice that if I click here, it takes some time before it will do what? It will update. I click again, you see. See, at this point it is no longer taking time now. So that is one of the issues. So if I refresh this page again, and I click here, you notice it's taking time now. You can see I'm pressing, but it's taking enough time. And why is it taking this enough time? Because that is when this visualized image here is trying to load its content. So at that point it lags, but after that time it stops. So how do we optimize this? So one way we optimize this is to come to our window does this. That is our window visualize, and put react.memo, wrap it inside our function. Now before we do this, I want to show you something first. Let's create, so we have to restructure this again. Then I'll put this as return, then I'll close it here. So if I do that now, I can have a console log count, window visualize rendered. So I'll just copy this, Ctrl C, Then I'll come to my optimization tool here and put the same here. Which is optimization 2. Render this. So we have this now. So if I click on this, you notice the data page is not rendering. It's not rendering. So I think for us to enjoy this, we need to have a state that changes within this page, and this is because at this point now we have optimized this counter by putting it in its own function. So I'll just copy this, Ctrl C, and add this to our optimization tool here. Then I will import my UseState. Then to keep this simple, let me call this out, close that out. Then to keep this simple now, I need to pass this as a prop to my counter so that everything will work. So I'm going to pass this as a prop, which is this add count equal to add count. So I save that. So I come here, I accept it. Add count. So that is not meant to be here. So I'll cut that out, save that. Then it's meant to be in my counter too. Then I need to comment this out and this out. First of all, then I need to also pass in the count. That is the counter. So next I will do that here. Passing the counter. Okay, so that is it. So if I do this now, my counter, I'll fix this. So if I do this, this is how many times it rendered. Stop at visualize from rendered. So if I click this again, I see the window the window is rendering, that visualize window is rendering, and the optimization page is rendering. So if I click again, so you see that you have 5, 6 and 7, 8. So let's check again. So we have 3 and that did not render. So let's do that again. So we have 9, 10, that is window optimization rendered, then optimize this also rendered. So you see that both pages are rendering. So let's do that again. So you see that I have my visualize window 1, 2, 1, 2, optimize and visualize. So let's do it again. So we have 3, 4 and 3, 4. So you see both states are changing. So I update something in my optimization page and is affecting the component page. So how do we do this? So to also show you what more is happening, I can come to my lazy load image. Here also I also put a console.log count, and I'll put lazy image rendered. So let's repeat the same process. So if I click here, you notice I have optimization. What do I have there? So I need to refresh this. So you notice I have this now. So if I clear this and I click here, I have optimization 1, 2, then you see lazy load image 3, 4. I click again, you see that is much. So you see that there's a delay, and I'm having optimization to 3, but you see this one is 5, 6, 7, 8, 9, 4, 4. So let me click again. So you see it's still rendering. It's rendering the 9, 10 now. Here again, I see 11, 12. Now for a state change that only affects the optimization and the counter, but you see that it's affecting this guy that is in the load image. So in order to fix that error, we come to the lazy load image and add this react.memo. So this will prevent it from any state that does not concern it. It will not work. It will not work. So if I refresh this again, so you see the lazy load image rendered for 4 times. So if I click this, it will still lag, and it will show me T8 now when it updates. So you see, okay, 6 now, but now it has finished loading at least this first section. So we say bye bye to the rendering of what? Of the lazy images render. So if I click now, you see the lazy image does not render, and that is why you see that the page is now a little bit faster. So you see that in the first example, I optimized this counter by putting it into its own function and isolated it from the optimize function, so that after the page finished reloading, you see that the click is now faster. And we have also been able to do that using another scenario. We have the state that is changing on the optimization page, but don't want it to affect this lazy images. So you see that the page has been what? Optimized now. So even though I scroll down here, I still come down here and click here, it's going to click or respond within seconds. So that is how we use the use memo to avoid a re-rendering when a prop does not change. So you see that it's still the same prop, so why should it re-render 5,000 images all over again? So that will definitely lack your page. I mean 500 images. Is it 500? It's 5,000. So the next thing that I want to learn now is the use memo. So the use memo hooks optimizes performance by memorizing the result of a function call or an expensive computation. It caches the result and recalculates it only when the input value change. So memorize expensive calculation, count, and a count dependency. So the use memo is used to do what? Is used to save the result of a function. That's what a function returns. So let's create a mini example. So let's say I have in my optimization tool. So let me create a function. As a function get count power so whatever the power is, I want to get it. Then I'm going to now put set the set timeout. Then the time here will be 1000 times 15. So that will be 15 seconds. Then after that, we want to run this code, return counter nine raised to the power 9, 2 raised to the power 2, 3 raised to the power 3. So counter time times counter. So if we do this now, I want to pass it as a prop to here. To here. So let's see. Says the use memo. Okay, just used to do that. So let's do this. So if I go back to my code, I can say, I can put here h3 counter has a power of get count power. So if I save this, so let's see what it will show on the console. So our current count now has this, so it has the power of this, so we're not getting the counter power. Return. Let's see why we're not getting that. Okay, so what the correct count now is 20 has the power of what? No, that is not it. So 20 should have a power of that is very big. So what we are just returning is this. So I wanted to add a brief delay. But that is not working. Okay, let me use another technique. So we can return that. Okay, so let's just use the normal one, which is this. So I'll skip, remove that. So if I save this, I'll be having this. So you see the power now, very big. So if I count this now, show me 1, I count this, to show me 4, I count this, to show me 27, this one, so it's just like that. It is going to be adding. So with the use memo now, I can now decide when I want this to update and when I don't want it to update. So the use memo is used to store the result of a function. So what I can do now is this. I can put here let memo power be equal to use memo, then as the first argument is the function, which is get counter power, then a dependency array of how many times I want it to run, or which of the components I want it to be dependent on. So let's do that. So the use memo will be a function that will return something, then this. Okay, so let's see. So if I increase this now, so I have to refresh again. So if I count this now, 1, you see it takes time to load 2. So next, what I'm going to do now is, instead of using this, I will now use this memo power. So let's see that. So you see that we are still having the same thing. So if I click on this now, you notice that the power does not what? Update, because I don't want it to do what? Update. So you see, as I click, the power does not have to update. So if this was another state now, because I don't put anything inside its dependency, it is not changing. So if I put the counter here as a dependency of it, then that is when it will change. So now you see. So if I do this, you see it changes. So that is how we use the use memo. You can use it to decide when a computation should be done or not. So if we want to make this more interesting, we can create another state here, but I believe this has done the job. But let's do that. So we can create another one called cat. Set cat. Then it should be 0 2. Then let's just add a button here. So we'll select. So we'll put here cat as the power of this. So if I come here and I put my button cat plus plus, and I put here on click, set cat to be cat plus equal to 1. So if I do that, now you notice something now. I'm going to add the cat here. So it's only when the cat updates that is going to show me this cat has a power of this. But if I update the counter now, because the counter is not part of this dependency array, this calculation will not be repeated. So let's try that theory. So that is it. So if I increase this to I think I'm still using the old one. So this is going to be cat, and then this is going to be cat, so that it reflects accordingly. So if you change to 4 now, 4 icing, so it's working. But if I increment my counter now, you see it doesn't have to be what? Recalculated. So there is no re-render now. So the use memo is used to store the result of a function. So I've used it to store this function now, so it is not recalculating this, because cat has not been updated. So it's only when I update cat that this will work. But if I update this, you see, this doesn't work. So just like updating this will not make this guy to change, so you should not even try to even record a function. So that is for that. So the last one for here is using the use callback. So the use callback hook in reality is used to memorize a function instead of memorizing the function results. Just like our use memo, is particularly useful when passing event as prop to a child component to prevent unnecessary render. So instead of passing that add count to our counter component, we're not going to add it as memorizing increment than this. So we only want it to increment if the counter increase. If it does not increase, then there should be no render. So let's do that. So if I come here, if I tap this, you notice there is a rendering of the Windows app because this state is inside here. If I also click this too, there's also a rendering. So to do this, I need to add this. Let memo add the add count. I will now come here and pass what? Memo add count. So if I do this now, everything will still work as before, but this optimizes the web page. So you see, it takes some time before it will add to 1 to 2. It should take some time, but you notice after the image loads now, it does not take time again. So you see, everything is working the way it's meant to work. Very nice. So we'll optimize this web page to some extent now. Okay, so now the next thing that we want to look at now is this. We're going to look at the React throttling and debouncing events. So throttling and debouncing are used to limit the number of times a function or an event handler is invoked. They ensure that the function is called only after a certain period of inactivity. So to show you how to do this, I'm going to have a markup for a form. So just a simple form. So we are going to add that. Hey, my internet has gone off. No alarm, just off. Okay, so we are going to have an input field. So let's do that here. So let's do something like a search here. Open this. So excuse me. So a field set. So we need a label. We'll call it search. Then we need an input. So this will change to search name, search ID, search, then placeholder, search, search this website dot. So if we save this, let's look at our markup. So we have something like this. So if I click this, it gains focus and I can type. Then because I use the search here, I can cross this off. So what I want to do now is this: is anytime the person clicks here, even if it's just one button like this, by default, if we have the algorithm to search, that means anything that we just type, it will just dynamically begin to search the web, and that might be too fast and can lead to multiple render. So I'll show you that in a moment. So let's create a state here. So let's create a state, a hook. So let's differentiate between state and other things. So tab, so let search, set search, then use state, then put it as empty string. So what I want to do now is this: we now want to add event listeners here. So we are going to add the value here to the search, then on change we now have our nonce function, this set search to be e.target.value. So we can also add another event listener, which is on key up, so that as user press and release, then it will now call the handle search. Handle search function like so. So we need to create this function handle search, then we cannot have our console.log search, because at this point now the user has a search stuff. So if I cross this off and I backspace, I shows with an error. So you notice as I type, I get what I type in real time, and that is causing much re-rendering. So if I type here Amadi, so on the screen you see what? You see Amadi. If I backspace and type Chile, you notice I'm getting that in real time. So here comes the bounce now. We don't want to be calling this each time the person just press and release key. Will I want the person to finish typing and wait for some seconds before it will activate the search. That will increase the search efficiency and the speed of the website. So let me on my internet again. So my internet will be available within a short while. So we are going to use a package called Debounce, npm debounce, so that we are going to use it to test this application. So just a moment. So let's go to the browser, then let's type npm debounce, so that will load in a second. So that will load in a second. So we have the debounce here. Then I now have this. So to use the debounce, you have a function. So if you scroll down, you can import it by saying npm import debounce. So if you copy this like so and come to our second terminal and clean this off, why is it? So if I paste there now, I will have this. So that's nice. So if you hit enter, you will install that. I've already installed that. So understanding this basic example, we need to import debounce. Then we have a function that runs in real time, but I want to delay. Then we use sorry, excuse me. Then we use the debounce function like this. So let's do that. So inside this, so let's look at the documentation again. So here we import, and here we add this. So it's going to delay that now. So let's do that. So I can come here now and put debounce so debounce from debounce, I already have that. Then should be a parenthesis, open this, then I have the handle search, then I have what as the next parameter is the time I want it to be delayed, which is this. So I need it to be like 1500 seconds, I mean milliseconds, or 15 seconds. So if I save this and come to my browser, you notice now if I type something, it does not show immediately. It waits some time before it shows. So let's really add a big one, a big time. So let's make this is 15 seconds, so let's make it a minute. That's 60 seconds. So if I save this and I type A here, so no, that is not up to a minute. Amadi. So that should take longer than that. So why is it not doing that? So let's look at. So we have the handle. So I have this handle search, bounce. So we've already imported at the top. Oh, this is 6 seconds. I want 60 seconds because it's just 1000 times 6 that is here. So I know that is a long time. So if I remove this A here now, I think let me refresh this because we imported a new package, even though it's very light, but to still have its own effect. So let's wait for the image to load first. Okay, so the image has been loaded. So if I add this now, so you see how fast it is, lightning fast. Okay, so let's clear this. So if I type A here, that is why it's not showing. So I'm going to put here now, because why is actually not working, because here I'm still calling I'm still calling my handle search. So I should remove this from here, then cut this, Ctrl X and paste here. So this clinches it. So it's a very big mistake to type something and you forget to remove it. So now if I type A, let's wait for the images to load so that we'll be sure that the delay is actually from the debounce. Okay, so it has come. So if I click on this now, you see how fast it is because you have optimized that. This is also optimized. So now if I clean this, I type A, you notice how long it takes. It will take about a minute before it will show that I've typed A. So let's wait for it to show. A minute is not long, but it will seem long because you are waiting for it. So it will soon show. So we're about 50 something seconds now, or 45. Means my gauge was wrong. I hope that was not 600,000 because we wait forever if it's like that. Okay, I want to change this to 15 seconds for this 6,000. So before I save, let me come back again. So that time is too long. So let's save. That time is too long. We cannot use it to test our code. But it has served its purpose. It shows that our debounce function is actually working. So that is why we are not seeing the A. So let's check that we are outputting it here. Yes, you are outputting it here. So let's try this again. So let's wait for it to finish loading the images, so I will know the cause of the delay. So if I hit this now, so you see how fast it is. So let me clear this off. So if I type D now, so let's see if the D will come. It's taking too much time. Or is it because I'm adding too much time? I think that time is too much, so let's use the default one, 200 seconds. This is 50. Wow. Let's use 200. Those timing, they are actually very big, and I was waiting for it. So dinner. So actually our search this is no longer working. So on key up, debounce, search this is going to show us here. Well, we already have a function, so we are not using this debounce here. So let's fix that error. Debounce, resize, so you will not invoke it then. Oh, this error affected me yesterday too. So let's add this. That error has defeated me twice now. So if I type something, you see that it wastes time to show. So let's now add that our 15 seconds. 15, that is 1.5. So if I clean this up and type Amadi, you will see how long it took before it can display Amadi. If I say space Chile, so
So it's only when I finish typing and wait for some time that it shows me what I type. Now if we take that a little bit further, let's make this 30. So 30. So in order not to be confused, just always learn to use 1000 times the number of seconds, which is 30. So whatever that outputs is the answer. So I'll cross this off. I'll put bag. So you notice that it will take about 30 seconds of me leaving the search box before it will show me that I type bag. Which is half a minute. So 30 seconds is half a minute. So it will take this long just to demonstrate that it's working before it show me that I type bag. So you see, it worked. So that is how we use the debounce. So that means it will not be forcing this page to be rendering every time. So the next one we want to use here is code splitting. Now this code splitting is very easy, but we can use this to make sure that, especially in our components, in our apps page where we are importing so many components and use them in the routes, or in our route data component, we can lazy load. We can split our code and lazy load them only when they are needed. But we'll just do a simple one in this our optimized page. So we don't need to install any package. So code splitting in React is a technique used to split large JavaScript bundle into smaller, manageable chunks. It helps improve efficiency by loading only the necessary code for a specific part for an application rather than loading the entire bundle. So if my page has like 20 pages and each of those pages is like, let's say, is like 10 kilowatts. Is like 10 kilobytes. So by the time it loads the entire 20 at a time, I should be getting close to more than 1 MB of site. So loading all of them at once can reduce the efficiency of your this website. So you have to code split them and load them only when you want. So we import the lazy and the suspense. Then we can now have our dynamic content. Then we can now have a suspense and a fallback. So any dynamic component or code should be inside a suspense. Then the default, if it's delaying to load the page, we can add this loading effect. So let's do that. So I want to lazy load the counter 2. So I'm going to change this to a named import. So I just comment this out. Now put const counter 2 be equal to lazy then you enter your anonymous function, then import in bracket the path to the file. So put dot and forward slash. We have the counter 2 slash. I will now have the counter 2 component. So next I will now come here. So here we are putting the counter 2. Is here. So I can now add a suspense. Suspense, just like that. So I'll put that here. Then Then I can now have a fallback, which is this. So I can have a DVR or an error component, which is loading counter ... So if I save this and refresh, you're going to see the new output. So if I refresh this, if you scroll down, you're going to see the loading counter. So we were unable to see that because we did not scroll down. So let me redo this page. So I'll zoom that so here. So now I see you see loading counter and the shows counter. So we can also do the same thing for our images. So let's see if we can have more than one suspense. We can, but let's just try it. So I'll have the lazy image here. So I'll bring this down. So I'll just repeat the same thing, shift alt arrow down. I will change this Ctrl C to this. Then this will now be the path. So slash lazy image, not image 2, slash image 2. So let's see if I can have another suspense. So shift alt arrow down. Then I can call this out, and I'll move this entire div inside it. So I can now put loading images ... So if it doesn't work, we can move it to the first one. So if I refresh, you're going to see here it will show now. So you're going to see two loading. So you see loading the counter and loading what? You see loading counter and loading images, and see they came at the same time. So if you add the suspense or if you add the suspense as your outermost container, or you wrap everything inside a component inside that suspense, that means if the page delays for any reason, you can have a custom loader that will learn how to build in JavaScript, and you can display that while the user waits. But this is also good for this class. So if I refresh, you're going to see two loading. There's the loading image and the loading counter. See loading counter, loading image there. When it's ready to now show. So you see that by removing this content and showing only one, you see that the page was able to refresh as fast as possible. So that is how we optimize using the code splitting. Then the React fragments. So React fragments are features introduced in React 16.2 that allows you to group multiple elements together without adding an additional DOM node. So this is particularly useful when you need to return multiple elements from a component render method. but you don't want to introduce unnecessary DOM elements that could affect the layout or styles of your application. So you'll be seeing me doing this, and this is one optimization. This is one of the optimization technique. So let's see how we can add that. So inside this other one here, inside this counter, so if I don't want to use this, fit set, we also move it and add only this. So this is also a fragment. It then means there will be no fit set. So it just be like this. So you notice how it looks like now. Very nice. So that is, so there is no extra DOM node that is put there. So that is just it for that. For this, then we have make use of functions instead. So use the previous state props, then you return your function. So that simply means in my optimization, my optimization component, instead of doing this here, this is not good for optimization. So what is good here is to do set counter, then I will now use a function which will hold my previous state, then my arrow function, then I can now do the previous state plus 1. So if I do this, I'm now using a function, and this previous state includes or is only the initial value, which is what, 0. So if I save this now and go to my browser, the add count should still work as before. So if I tap here, so you see how fast it works now. It's not being optimized. So React loves it when you add a function there instead of just doing that first initial method. So that is nice. So we are done with that one. So instead of using this method, always use this, and it optimizes your React app. So now the next one is avoid inline styling. So we all know what inline styling is writing our CSS inside as part of the HTML table. So in order for us to optimize our page, we want it to be as small as possible. So adding inline styling will greatly increase the size of our page. So the last optimization method I want to teach you before the end of this video is the UseTransition Hook. Now the UseTransition Hook in React plays a pivotal role in improving the performance application by allowing the marking of state as non-blocking transition. This capability enables React to defer rendering for this update, preventing UI blocking and enhancing overall responsiveness. So here's a very simple example. So I have a state and I want this one to use the use transition, so that in case there is a delay, it will show the user. So the state that we put in our transition, we just want them to, according to the explanation, it says the capability enables there to defer rendering for these states. No, says the UseTransition Hook in React plays a pivotal role in improving the performance of applications by allowing the marking of states object as non-blocking transition. So the state that we did not use as transition, I think they are the non-blocking. Then the one that we use there, they are the ones that can wait until when there is space, then it will now show. So let's do that. So we have to create a UseTransition state. So we have the state and we have the start transition, and the start transition looks like this. So let's do that before we end this video. So what I'm going to do now is this. I'm going to come back here inside my counter, inside my add counter again. I'm going to create a hook called let is pending set or start transition, then equal to use state. I'll just leave it like, no, not use state, use transition, use transition. So what we want to do now is to wrap this inside here. So say start transition. So this is like our use effect, but only that it doesn't have a dependency. Then we'll put all this here. So what we can now do now is in our counter app. So here is the counter app. So the counter app is inside here. So just need to pass this state, which is pending. It's pending. So let's grab this, Ctrl C, and come to our counter to the structure that. So if for any reason it could not show the value, you're going to have a pipe symbol. It's not compulsory we have it here. Then can just add it here is a span tag of is pending. If it is true, and then we want a span tag of updating count ... So if we click and there is a delay, actually when we load our page, so if I click on this, you see it updates in real time. So let's come back. So you see, if I try to update it fast, it's showing me that updating counter. But let's refresh this. So notice is still loading the counter. Then after I finish loading, if I click on this, so you notice there's no response. So you see, so that is it for today's class for our Saturday. So thank you very, very much, and I'll see you in the next video, which is this.